I am Jonathan Arreola from the College of Architecture and Urban Planning of the Pamantasan Lungsod ng Maynila. And today we're gonna teach you how to solve the cantilever truss using the method of joints. So this is our problem. The cantilever truss is hinged at D and E. Find the force in each member. So this is the illustration of the cantilever truss hinged at D and E. So as you can see, joints A and B and C having the same forces acting on them, the 1000 Newton. So, to solve the cantilever truss using the method of joints, we must find forces acting on each joint. So, first, we go to the joint A. So, this is the free body diagram of joint A. This is the force acting on joint A, the 1000 Newton. So first, we're gonna solve for the vertical forces acting on them. So the summation of vertical forces is equals to 0. So the force AB times the sine 30 degrees is equals to 1000. So 1000 over sine 30 degrees, solving them will come up to the answer of 2000 Newton, which is a tension. So now we'll go to the horizontal forces. The summation of horizontal forces is equals to 0. So the force AC is equals to force AB times the cosine 30 degrees. So we already find out the force AB. So we're gonna substitute its value to this. So force AC is equals to 2000 cosine times the cosine 30 degrees. So force AC will be 1732.05, which is a compression. So this is the free body diagram of joint B. As you can see, there's the 1000 Newton acting on joint B. So to solve the equation, we use the method of revolving axis. So now this is the x-axis and this is the y-axis. So, solving the forces on y-axis, we found out that FBC is equals to 1000 times the cosine 30 degrees. So, we come up to the answer that FBC is equals to 866.02 Newton, which is a compression. And now we're going to the forces acting on x-axis. So the summation of them is equals to 0. FBD is equals to 1000 times the sine 30 degrees plus the 2000 Newton, which is the FAB. So solving them, we'll find the answer of 2500 Newton, which is a tension. And now we'll go to the joints. So this is the free body diagram of joints. As you can see, there's the 1000 Newton acting on joints. So we must first find out the vertical forces acting on them. So the summation of vertical forces is equals to 0. Force CD times the sine 60 degrees is equals to force BC times the sine 60 degrees. That's the 1000. So we already find out the value of the force BC. So we're gonna substitute it here. So solving the force CD will come up to the answer of 2020.72 Newton, which is a tension. And now we're gonna solve for the horizontal forces. The summation of horizontal forces is equals to 0. So FCE is equals to force CD times the cosine 60 degrees plus 866.02 cosine 60 degrees plus the 1732.05, which is the value of the force AC. So solving them, we will come up to the answer of 3175.42 Newton, which is a compression. To summarize the forces acting on the cantilever truss, so the force AB is equal to 2000 Newton, which is a tension. The force AC is equal to 1732.05, Newton, which is a compression, the force VC is equals to 866.02 Newton, which is a compression. Force BD is equals to 2,500 Newton, which is a tension. The force CD is equals to 2020.72 Newton, which is a tension. And the force CE is equals to 3,175.42 Newton, which is a compression. So that's how you find the forces acting on each member of the cantilever truss using the method of joints. Thank you for watching this video. I hope you learned a lot.